All right, so sometimes in calculus, we want to find the area of a region, which is a little more complicated than just the area under a curve. So here to do this one, I'm going to have to dissect it into chunks. And so I'm going to do so by seeing where the two lines, y equals x and y equals 9, intersect. And I'm just going to cut that using the line x equals 9. So I'm going to find the areas on each side. Now, we still have another problem. I can easily find the area under, say, the curve y equals 9. That would just be this rectangle over here. But I really just want the gray area. And so the trick here is if we had all of this area here, we could then just subtract the area under that other curve. Okay, and that would leave us the gray area behind. So if you have two functions, one on top of each other, like subtracting them in the right order will give you the area between them, which is kind of cool. And here I have to break that into two different pieces because we have the blue function is on top of the red one first, and then the black one is on top of the red one second. So this area is going to have to be done in two pieces with the definite integral. So doing the left piece first, to get the area, I need to let y equals x be on top. So for the first part, I'm going to have x minus the red function, x squared over 36. So the difference in those two functions is going to give me the height in between them. And so I want to integrate those as x goes from 0 up to 9. Okay. And essentially what that will do, it will find the area of the triangle under y equals x, and then minusing, subtracting the x squared over 36 will cut out the area under the parabola there. And then we'll have to combine that with the next area. And so the next one, so adding on, that one starts at 9 and goes over to 18 for x. And there, the curve on top is 9, and then underneath is the x squared over 36. So the first integral will give me the left side, the triangle on top, the line on top with the parabola underneath, and then I can get the other one. So just setting up subtraction in the right order allows you to get the area between curves. If the region is complicated, you sometimes have to break it into chunks like we did here. And so then it's just a matter of coming up with antiderivatives. So for the first one, an antiderivative for x would be x squared over 2, as we saw previously. And then I'm going to have to subtract, and I'm going to pull out the 1/36 here, and then just consider an antiderivative for x squared. And we saw before that if we raise the power and divide by the new power, that'll work. And so that's the antiderivative for x squared, and we have that 1/3 hanging out. And this chunk needs to be evaluated from 0 to 9. And then we have that other integral over here. And so that one, I need an antiderivative for 9, which should just be 9x. And then we already have the antiderivative for x squared over 36. So then I'll have a minus x cubed over 36 times 3. And that chunk gets evaluated from 9 to 18. And then you just go in and plug in order your boundaries. Always nice to have 0 as a boundary for some functions because it comes out to 0. So usually I switch my style of parentheses to a curly bracket or a parenthesis once I'm evaluating. So let's go with, I think a regular parenthesis should work fine here. I'll have a 9 squared, which is 81 halves, minus 9 cubed. I don't know what that is off the top of my head. divided by 36 times 3. And we can do some cancellation there. And then when I plug into 0 to either of these, I get 0. So there is nothing to subtract there. Moving on to the next one, that's going to be a bit more work. And I'm not sure if I have enough room to fit that here. Let's see. So we'll get a 9 times 18 minus 18 cubed over 36 times 3. And again, there'll be some cancellation there. And then we'll have minus another set of parentheses, 9 times 9 minus 9 cubed over 36 times 3. And so now we just have a whole bunch of arithmetic to do. So at this point, I'd be whipping out my calculator to get an answer. But I guess I could have fun with fractions here. So let's see, what do we got? Here, I'm just going to leave that as 81 over 2 for now. But up here, I can do some canceling. So let's see, 9 does go into 36 4 times. So that would give me a 9 squared and a 4 there. And then one of those 9s I could take 3 into. So that's going to give me what, 3 times 9 left over 4. So that's 3 times 9, 27. So I'll have minus 27 fourths from that one. You guys probably already worked this out on your calculator. I feel like doing arithmetic today. Oh boy, 9 times 18. Let's see, 9 times 9 is 81. Doubling that gives me 162. So I have 162 there. 18 cubed. Let's see. Let's see, 18 times 2 is 36. So I can get rid of 1 of the powers there. And then 3 goes into one of those other 18s 6 times. So I can get rid of that 3. And this is going to become a 6 times 18. Which isn't so bad. And let's see, similar thing happens over on this last fraction. I have one of those 9s goes into 36 4 times. And then this 3 goes into one of those 9s 3 times. So the 3 times 9 there. Okay. Where does that leave us here? Oh, that 2 goes into that 18, doesn't it? Let's see that. That's lovely. Okay. So, what do we have left there? 6 times 9. Right? So we've got minus 54. And then subtracting the left-hand evaluation, be careful with your parentheses. 9 times 9 is an 81. And we're stuck with a fraction there, about 27 fourths again. Okay. And I think that's enough on the fractions. Now it's time to whip out the calculator. So let's go ask. I could ask GeoGebra, I think I'll just ask Google. So I've got parentheses 81 over 2 minus 27 over 4. Now the downside of the Google calculator is going to give me a fractional answer plus, and parentheses there, plus 162 minus 54 minus parentheses 81, take away 27 fourths. Looks like if I type that right, let's see, 81 halves minus 27 fourths, yep, 162 minus 54. So if my fraction reduction is correct, that all looks correct, I get 67.5. So 67 and a half. So it looks like this is 67.5. And to double check that, I could just plug in the original calculation. Where'd you go? There we are. Plug in this before the red canceling and see if that works. Alternatively, I could go somewhere like GeoGebra and type in my original integrals. So I guess I could try that in a couple of different ways. Let's see. Where's GeoGebra? I know I had that somewhere. Here we go. All right, so let's see. I want to find the integral. Function 3 there. Function start end value of my first function. And I can't combine these in one. It's got to be two different parts. So it's going to be x minus x squared over 36, evaluated from 0 tab to 9. Gives me that chunk right there. And notice it's graphing it for me. It's not graphing that y equals x line. Notice that does have a curve to it. It's graphing the function x minus x squared over 36. So this is a different picture than the one I started with. All right, and then I want to add on to that another integral. It's all in one line. And here the function is instead 9 minus x squared divided by 36, starting at 9 and ending at, oops, that's in the wrong spot. Get out of there. There we go, starting at 9 and ending at 18. And let's go with enter. And GeoGebra agrees that 67.5 is the answer. Now, it doesn't show me any work in between, so GeoGebra is a good place to check your work. But on a test or on a quiz, I'm going to want to see a whole bunch of work. And so I'm going to need to see stuff like this, antiderivatives evaluated, and then whip out your calculator. All right, that's it for this one. I will be back soon. Have a good day. Do good math.